Today we are going to talk about network analysis. I'll talk a little bit more about exactly what that is in a minute. So I spent the last 20 years working in various technology jobs. I decided to take a little break from working. I don't know how many people consider going back to school to get a PhD a break, but it's actually been kind of nice. The academic lifestyle compared to the startups, a little slower, it's a little good. These days I'm mostly doing research for my PhD, which is focused on better understanding how Linux kernel developers collaborate with each other when many of them work for competing companies, which I find pretty fascinating. But this presentation will include some basic network analysis. I'll show you how to do that, and it actually uses one of the Linux kernel mailing lists as an example. So you'll see that in a bit. So network analysis, it's also called social network analysis, network science, has a few different names. I tend to prefer actually not to use the term social network analysis, even though it's probably more accurate, because as soon as you put the word social in front of the word network, people assume you're studying Twitter and Facebook, which, while that's fine, that's not actually what I'm doing. What you see here is a very grossly oversimplified definition of what network analysis is. So, because it's a fairly complicated discipline. So the best way to describe it actually is by just giving you a few examples of how people use network analysis. So today, we're going to look at it to look at the relationships and the activity of people participating in open source projects, which is one thing you can do with it. The example graphs on this slide actually come from one of the professors at the university she's looking at networks of people with eating disorders. So that's what you see here, are networks of specific people with eating disorders. It's also used to study the relationships between organizations themselves. So you can use it to study parent-subsidiary relationships. You can use it to study which companies have similar people or the same people on their board of directors, for example. And this is one of the more interesting uses of it. People are also using it to study animal social networks. So they're looking at things like dominance behavior between horses, or food sharing between birds, which is an interesting application of the discipline. There is actually a guy at the University of Greenwich who is also using it to study medieval people from Scotland, and he's doing a network analysis of people from medieval Scotland using things like witness signatures. So he's going back and doing historical social network analysis, which I find kind of fascinating, actually. And you can do some very advanced analysis, looking at things like relationships over a period of time and using statistical modeling techniques to then predict behavior based on what's happened in the past. So we're going to talk about four primary things today. We'll talk about gathering your data, so how you get the data out of your open source communities and into a database where you can do this type of analysis and run the queries you need. We'll talk about how to manipulate the data to get in a format that's easily used by the network analysis tools. And then we'll try to spend most of the time talking about how you can visualize the data to see how people within your community are interacting with each other. And I'll show you a couple of ways of doing this. And finally, I'll spend just a few minutes at the end to talk about some other things you can do with network analysis. And just a quick plug that it is more than just the pretty visuals. Since I don't have a ton of time, I am going to go through things relatively quickly. However, you can find all the detailed instructions at the GitHub repo. So it has a README with almost exactly everything I'm going to do once we get to the code examples. It has a link to this presentation. It has all the scripts I've used. It has the data sets. It has everything you would need to replicate this if you wanted to do a similar analysis with your community. So you don't have to worry too much. As long as you have that link, you're good. So the metrics grimoire is the go-to set of tools that you will probably want to use to gather data from your open source community. You can use these tools to store all this information in a database, where then you can write queries and extract the information that you need. I've listed a few of the more common tools, but the grimoire has a bunch of other tools as well. In this talk, I'm going to focus my analysis on the ML-Stats data, which is the mailing list data. In my research, I also make heavy use of the CVS Anali tool. However, when I tried to show both of those within a 40-minute time slot, that wasn't possible. So we're going to stick with ML-Stats. so that I can finish on time. Just as a reminder, all the stuff's in the GitHub repo, so you can see all these steps. But the way this basically works, in short, you need to actually install the MLStats tool. It's a Python program. It's relatively straightforward. And then you need to create your database and run MLStats on it. And this will take all of your mailing list data and put it into a database. One catch to this is that if you have a very large mailing list, this can take a very long time. So keep that in mind. If your mailing list is very large, you probably want to run it on a server somewhere where it can just chug along rather than on your laptop, your poor underpowered laptop. You might also need some slightly different configuration options depending on your particular setup. So what I've shown here in this last step is just, if you're running it with the database on localhost and you have a very simple setup, that will probably work. MLStats also has a bunch of other options. So if you've got a more complicated setup, you've got your database in another location, it can handle all of that as well. And then if everything goes well, you end up with a database with all of this data that you can use to to extract some query or to run some queries, extract some data. And just so we don't lose sight of what we're doing, this is what we're going to end up with on the end. So at the end of all this, we'll end up with a graph like that, or a network like that. So the MLStats wiki is quite useful. It actually has some sample queries. It has the database schema. So if you're writing your own queries, that's quite useful. This is the query that I used to gather data for the network analysis. Again, it's all in the GitHub repo, but I can kind of walk you through it. So like the first piece of it is really pulling out the email address of people sending emails to the mailing list. It's pretty straightforward. And then the piece in parentheses is the subquery. And what that does is it looks at the email that person sent and figures out what it was in response of, and then it pulls out the email address for the person they responded to. So what we end up with is something like this, where you've got the sender email and then the person that they were replying to with the email. And then if it's a new thread, the second one is just null. And then I also limited the time just to get a more manageable data set. So we had a smaller network where you can really see what's going on. So I limited it to January 2015. Everybody with me so far? Any questions? Okay, keep going. But for most analysis, yeah, there's a question. This MLStats tool. Yeah. So it basically, you install it, you create a database for it, and this actually takes the data from the URL of wherever the archives for your list are, and then it pulls it into a database. Mailman archives, Gmail archives, anything that's in an MBox format, it has some pretty flexible options, actually. Yeah. But for most analysis, I generally try to script it out so that I'm not just running standalone data queries or database queries and then reformatting data on my own, because it just makes it easier to do some cleanup of the data, makes it reproducible so that if I need to do this again, I can figure out how I did it. And it reduces human error, which I'm really good at. And for your convenience, in the OSCON repo, there is an oscon.py script. So that actually has the script with all of the, basically, it has all of the stuff in it that I use to create the data sets. So you can take a look at that. And you give it options for what database to use, where to store the output files. So you could actually use this script with your own mailing list data. And you should be able to get something fairly reasonable. Offered with the caveat that I'm not an actual real programmer, so your mileage may vary. But it's a reasonably good starting point. Since so we're going to use a few tools. We're going to use R, which I'm going to use RStudio for. You don't need RStudio, you could just use R, but it's a little bit easier to do a demo using RStudio. But since I don't want to turn this into an R programming class, I'm going to breeze through quite a few things that we can do in R to generate some of the network data. So I'll try to explain as much as I can about what's going on, but it's a little bit little bit complicated. But the R script that I'm using, again, is in the GitHub repo. So you'll have that. And then we'll generate the new data. Sorry, I keep doing that. We'll generate the new data file. I'll show you how to make a nice, pretty graph using a tool called Visone. And show you, if we have enough time at the end, I'll show you a way to use Gorse with custom data. How many of you have used Gorse to visualize your source code repos? How many of you have used it for something else? Okay. Gorse is awesome. So everybody should look at Gorse after we're done with the presentation. The GitHub README file also actually has instructions for skipping R entirely and going to Visone, which is a little bit easier. The output that you get won't be quite as nice. But with that said, I'm actually going to transition to RStudio for the next piece. Okay, here we go. This is the fun part. So again, this R file is in the repo. It's got as many comments as I could think of to include to try and explain what I'm doing. We do use, some of the later commands use the iGraph package within R. So you would have to, for example, install that package. It's already installed. The library commands how you load a package into R. So we're going to start doing that. And then the next thing, we basically need to take the output from that Python script, which we talked about earlier. It's a simple comma-separated file with email address of the person who sent it, email address of the person it was in response of. So we read that. We do a read table, which reads it into a table. We tell it where the file is. We tell it that it's comma separated, and we let it know that it does have a header. So that's also relatively straightforward. So this creates a table object within R. And then we can just look at it, make sure it looks good. So we'll take a look at it. So we can see that there are 354 actions that happen where somebody responded to somebody else. And you can see, scroll up to the top here. You can see that there's a header. There you go, sender email, responsive email, and then just the full list of all the people who responded to somebody. I actually, I did also filter out people responding to themselves, I think, because that's not particularly interesting when you're looking at a network of people responding to each other. Because you get that a lot, actually, when people are sending mailing list messages. Just the way it works, I guess. So then what we're going to do, these two commands are basically getting the data in a format that we need it to get to the next steps. So these are not particularly important. It's just a matter of getting to the next steps. So the first thing we do here is we basically convert the mailing list table that we just created, and we basically tell R that it's a matrix. So we're converting it to a matrix. And then this next one takes the matrix because the edge list needs to have a matrix. So you take the matrix, tell it that the actions are directed. So what this means, and when you're talking about network analysis, there are two ways to look at it. There's either directed or undirected. So if I send you an email, then that has a direction. It goes in one way. But if I meet Morgan at a conference, the two of us met. There's not a direction. She can't meet me without me meeting her. So that would be an example of an undirected tie. Email, for example, is directed. So that's what we're using here. Go ahead and run that. And then what we're going to do, so when you look at the data here, you can see that there are people who respond to the same people a lot. So it's actually easier if we take that, and instead of having the same person responding to the same person 10 times, what we want to do is we actually want to weight that. So the two of them have had exchanges with a weight of something, depending on how many times one of the people has responded to the other person. So that's what we're doing in this first one, in these next two commands. The first one just says that every weight is equal to 1. The reason it needs this is because you can also do complicated weighting things where you would have one attribute that gets a weight of like half and another attribute that gets a weight of 2. So we just need to specify and make sure that R knows what the weight is. And then the other thing we're going to do is we're going to simplify what's called simplified. So it converts it into a simple graph that doesn't have any loops, which is people responding to each other. I think I already filtered that out of the data set. And it gets rid of all those duplicate connections to people and gives them a weight. So you can see here that it basically just takes the graph, and then the weight is just the sum. So if I emailed you 10 times, we would have, it would be a weight of 10. So we can see what that looks like. And then, I am going through this really fast, which I know, mainly because it's, we want to get to the interesting bits, right? But what I want to point out is that you can also, this question mark and then any command helps, basically gives you the help files for that command. So you can actually look at any of these things that I've done in here, and you can see exactly what the options are, what it's doing. So if you want a little more detail, you can dig into that a bit. With that, I'm going to show you, so the reason we're using some other tools to visualize the data is that while you can create nice visualizations in R, it's not straightforward. The plotting can be rather difficult and rather complicated. So I'll show you what it looks like if you just do one sort of a default plot. So you get something that looks like this. So things are on top of each other. It's not interactive. You can't drag things around. It's not particularly useful. Like I said, there are ways to make this look nice in R, but it takes a while. But I'm going to show you another way that you can. This is what we needed iGraph for, I think, was the TK plot. So this is another way of plotting within R that's much better. Not quite as good as the one that I'm going to show you in a few minutes, but this is basically going to give us an interactive network visualization. So we can look at the network, and then I'm just going to fit it to screen so we can see it. So here you can see that basically what we've done is whoops, you know what? We're going to go back to R for a minute. I'm going to explain what this command does before I run it. So basically what we're doing is we're taking this graph object that we created, we're giving it some colors, and then we're telling it that the edges, so those mean that the links between the people, what represents person A emailed person B, we're using the weight to adjust the width of the line. And then I'm dividing it by 3 just because the lines were gigantic. So sometimes you have to play around a little bit with the math just to make things look good. I think I made the arrows a little smaller. And then the vertex size, so basically the node size, so the size of the bubble is what we call degree centrality. So if I have had 20 exchanges with people, then I would have a bigger bubble than someone who has had 2 email exchanges with people. So now this graph is going to make a little more sense because now you can see that, so like Jorg Rodell, for example, is one of the maintainers for this particular subsystem. So you can see he's got a relatively large bubble, and you can kind of drag that around. So if you wanted to put him up here so that you could see it better, you can move some things around so that you can see things. But again, it's not particularly lovely, and but you do see some interesting things with this, right? So you can see who some of the key people are within the community, right? Because they've got these nice big bubbles. But you can also see that there's some interesting stuff going on. So there's this right here, which is Varun emailing this one guy, Emilian, a whole bunch of times. I actually looked at this, and what happened was Emilian sent a 26 email patch to the mailing list, which actually in the kernel community is not that unusual because you have to break it up into certain size patches. But Varun then responded to each individual email with feedback on those particular parts of the patch. So you end up with this gigantic exchange between these 2 people, but all related really around one patch set. So this was something that you would see in January, and because the data set was limited to January, you might not ever see again, frankly. But who knows? So that was kind of interesting. That made me go back to the mailing list and see what in the world happened there. Any questions on how we got to where we are now? Before I show you, I'm going to show you another way to visualize it that I think looks a lot better and is easier, frankly. Okay, so we're going to run one more thing. Basically, what this command does is it takes the graph object that we were just working with and exports it into a dot format, which I used the dot format. Doesn't matter, there's a bunch of formats. But it keeps the weights that we've already calculated for the size of the lines. And it's a format that can be easily imported into Visone, which is the tool we're going to use next. So I'm just going to run that. It's going to create a network file. We're going to ignore that warning message because it doesn't mean anything. And then we're going to go to Visone. I have notes just to make sure I don't. It's the thing with these GUI apps. You can't just like put a script out there. You have to remember what to click on and when. But again, so you don't have to necessarily follow along with everything because it is all in the GitHub repo. The README has all of the steps and everything I clicked on. So the first thing we do is we open that dot file that we just created. So we're going to say dot files. We're going to open this one up. And this is actually the same graph we were just looking at. It looks a little bit different because we haven't done anything to it yet. This triangle up here in the corner gives you sort of a quick layout. It tries to optimize it for what it is. And then you've got these various zoom lenses over here. So you can zoom to fit, which is what this is. You can make it full size. You can zoom in a little more. What we have here is not yet particularly interesting. It has numbers instead of names. You can't really tell what's going on. So we're gonna fix some of that. So the first thing that we are going to do is add names because that's quite useful. So we'll add some labels, node labels, which are in the vname variable or vname attribute. Visualize that. So now we've got names. Step one. The next thing we're going to do, we talked before about how we used degree centrality to calculate just the number of connections that were coming into a particular person. So we're going to calculate that again. Let's see. Yep. OK. Now, that didn't actually do anything because we haven't visualized it. So we haven't told it what to do with it. We just made the calculation. But now we can map it to the size of the node. So we can take size, node area, and instead of uniform, we change it to degree, which is what we just calculated. And now we visualize that. And now we end up with something that is a little bit more similar to what we had before. So we have, you can see some of the key people again, very similar. But it's a little hard to read. It's not, the colors aren't that great. So maybe the next thing we'll do is take this and change some colors. So again, we want to make sure that the attribute that we're coloring on is degree. So the people with the more connections to other people will have a darker color. I'm going to adjust the colors a little bit because you can see this maximum, this really dark blue. Once we put black text on top of it, it's not going to be particularly visible. So I'm going to change that as well. We'll just dial it back a notch. And then I can actually take this all the way down to white. And then we'll visualize that. And so now we have some nice colors. It's still a little bit dark, but I think that's all right. It's relatively readable, especially if we zoom in just a bit. And then the other thing we can do is we can, the arrows, we can also color them by the number of times that a person has responded to someone else. So in the last chart we did width, which you can also do here. But I think color actually makes it look a little bit better. So we're going to take the color and do the link color based on the weight. And then we'll use green because I like green. I think it looks pretty good with blue. I'm going to take the minimum color and actually darken it just a little bit because that's going to be really hard to see if we leave it that light. Then we visualize that, and now you can see, and I'll zoom back out just a bit. So now you can see that, scroll up here. Now you can see that the people with the darker arrows are the people who are responding to each other more than others, which I think is pretty interesting. So you can see the same thing where you've got, I'll just make this a little bigger. where you've got, again, you've got Varun responding to Emilian quite prolifically. But then you can also see, and it's sort of interesting to look at this because you have a lot of these key people, right? You've got Jorg Rodell, who's one of the maintainers, and you can see that the key people also reply to each other quite a lot. They have pretty strong connections, which is interesting. And then you can also export it. So we can take this graph, we can export it into downloads. There are a million different types of things you can do with this. So PNG is easy, but you could also do SVG, you could do PDF, you could do all kinds of things. So we save it. You can either do it as a region. So you could, if you wanted to zoom into a particular thing and then just export that, you can just export the visual area or visible area. We'll do the complete graph at the original size, but you can also change the width and the height, which is really useful if you know you're going to embed it in a blog post or in a presentation. And you can just change the width and the height here, and it makes it a little bit easier. So we'll do that. We'll take a look, and you can see here that we have the network image, which looks pretty much like what we were just looking at. Any questions so far? Well, this is a lot of stuff, but there's a whole repo with all the details, which is my excuse for going through everything too quickly. I'm gonna close some of these, and yeah.
In addition to using the number of replies per way, can you insert like the nature of the reply as something to measure? Like, is it a question? Is it an answer? Is it does it have more plus ones or something like that?
Yeah, you can actually do quite a lot with that. It becomes more complicated when you have multiple, what we call multiple attributes. But you could have anything as an attribute. It could be the type of email, whether it was a patch or whether it was a bug report, something like that. You could also have something like company affiliation as an attribute. You could have anything you can possibly get the data for. You could have as an attribute and use it in some way in your visualization.
Where would that happen in the R scripts?
It kind of depends on how you do it. You would probably include it in the R scripts because you'd include it in the table, and you would include that information there. So it would be right in the table and right in the matrix. But like I said, you can't actually go straight to Visone. It's a little bit harder to get things to look right. But you can do quite a lot within it. Yeah. But like I said, the network analysis can be quite complicated. I'm showing you what sort of the simplest example I could find that would be meaningful, that would give you some data that would be actually useful to you. But the next thing we can do, because we do have a few minutes, is I'm going to, since a lot of you haven't used Gorse on your repos, I'm going to show you what that looks like. But what I've actually done, the oscon.py script that's in the GitHub repo also takes the data, and Gorse has what's called a custom format, custom data format, which is a pipe-separated file with any kind of data you want to give it. So I created a pipe-separated file with the exact same mailing list data that we just looked at that we can also visualize within Gorse. So, so you can look at the GitHub repo to see exactly how I did that. It's in the README of the repo, some of the details, and then more of the details are in the Python script. But first I'm going to show you how most people use Gorse, which is you basically, I'm not going to talk about exactly what these options do, but you basically give it a Git repository, SVN repository, whatever you're using, and run it. And what you end up with is, so this is an example of the code for the website that we use to run Configuration Management Camp, which is a yearly event. So you can see Chris creating much of the stuff. I'm the yellow one over there correcting some typos. The guy in red was doing a bunch of CSS work. And then you can see as we get closer to the conference, you start to see, we've created all the rooms. People are editing those. And I think around here, we're starting to decide what talks are going to be accepted. And so you can see a big flurry of activity there. And so we're, determining the agendas for each of the rooms. And then, once we get to January, you start to see people, kind of finalizing, getting ready for the event. The event was first week of February. So you can see this big flurry of activity as we're getting, leading up to the event. Lots of stuff going on. The event's over. Now people are still, adding some files and PDFs with the presentations. And then you'll see that now it's September and we're doing this again. We got another year. So now we're going to move 2014 off and create 2015. If you've never run this on the code for your open source community, I highly recommend you do. It's fascinating. And people love to see it. And they also love to see themselves up there. They like to see their friends. Oh, I know that guy. He committed the whatever. So it's really a really nice tool. It's incredibly easy to install, and it's incredibly easy to use by default. There's also a million options you can use with it, like anything else. So you can do some cool stuff with it. So with that, I'm going to skip to the next part. So this is, and this doesn't look quite as good because I am sort of forcing the mailing list content into a tool that it wasn't exactly designed for. But what we're going to see now is we're going to see the exact same data that we just looked at in the network, but we're going to see it created over time, which is sort of interesting. So I created a new box just so you could see the new things coming into the mailing list. And then you can see as the people are responding to each other, and you can mouse over it to see, individual people. What I wanted to do that I didn't have time to do for this was figure out how to put that into a better tree structure so that they're not all clustered in the middle. I think it's totally doable. I just didn't have a chance to write the scripts that would have required the data to do it. But here, again, you can see, you see all the key people sort of floating around and replying to each other. So this is the exact same data, but visualized over time, which I think is pretty cool. And you can actually use the custom formats for a lot of different things, as long as you can get a pipe-separated file with a Unix timestamp, a person doing the action, a username, and then some kind of action, and then a file or another person that action is connected to. You can do this pretty easily. You can also do things like change colors and things like that within the custom format. But it's pretty cool. We just watch it. It's mesmerizing. With that, I'm going to go back to my presentation. Because I do have one more slide, and then we can go to questions. So the first thing I will point out, I showed you a couple of options for how to do the visualization using R and Visone. There are so many different options to visualize this stuff. I picked Visone because it runs across all operating systems, and it's a relatively simple tool to use. Some of them are incredibly complicated. Some of them only run on certain operating systems. A lot of the network analysis is done on people use Windows, so I'm sort of sadly at a disadvantage on some of them. But how many people do Python? Like write Python? Okay. So Python has some really amazing packages to do network analysis. There's one called the NetworkX, I think. And I haven't had a chance to play with it yet, but a lot of the people that I know who do network analysis use these network packages with Python. They're incredibly flexible, they're incredibly powerful, but you have to know some Python to be able to use them. But those are pretty powerful to use, and on my short list of things I need to do next. The final thing that I do actually want to stress is that network analysis is really so much more than just having cool graphs that you can look at. The cool graphs are actually awesome. So they give you something to put in presentations, they give you something to talk about, but they are also generally a first step towards understanding your data. So those of us that are doing network analysis, we tend to like to visualize the network because you can look at it. And like I did with those two guys that were replying just to each other, I was like, what happened there? And then you can do more analysis. This was a fairly easy example because I could just see what happened. But you can do more analysis as well. And the next steps usually involve a lot more calculations and measures to really understand what might be going on. And one example, so what we did here is we changed the node size using degree centrality, which is just the number of connections that you had with somebody else. That's actually probably an simplification in a lot of ways. It's simple because it's easy to explain. The math is not hard. But there are actually some much more sophisticated measures that you can use that really help you get at the influence within your community. So there's one measure called betweenness centrality that has big formulas and stuff. But what it basically does is it looks at the influence of the other people that you're connected to. So for example, if I'm in the Linux kernel and I talk primarily to Linus Torvalds and Greg Kroah-Hartman, and those are the only two people I talk to, I might be more influential in the community than somebody who talks to 10 people, if those 10 people aren't particularly influential. So there are other calculations that have a lot more math that look out into the network to see who else has influence that you're connected to. So you can do a lot more complicated things with it that are, frankly, quite interesting. With that, I'm actually done, so thank you. We have 4 minutes for questions. Yes? Data from Discourse? I have not, only because it's not used in the project that I'm studying, which is the Linux kernel community. You can do network analysis with just about any type of data. People use it with Twitter data, Facebook data. I imagine that it could probably be used with Discourse data. But I haven't done it because it's just not something I'm going to need to do. Yeah?
One of the challenges I've had with using metrics grimoire is getting a hold of the raw data. Is there a repository like SQL dumps for, like I don't want to have to go back and regenerate the mailing list data that you just demonstrated. Is it available already pre-populated?
Like, no. I mean, I could give you a dump of the database, but this particular mailing list, I used the Linux kernel IOMMU database, which is a memory management portion of the kernel. I used it because it was fairly small, fairly easy to import. It's a good example project. The data is nice and clean because it's in Mailman, whereas the stuff coming from Gmain isn't always quite as clean. But the idea would be that you would take this and run it on the mailing list that you're doing within your community. And you only need to run it once, and then you've got the database generated. You would need to run it more times if you want to update it. But.
And sorry, one other thing. Do you have any tricks for collecting company affiliation?
Haha. No, there's no easy way to do that. I got a data set from Greg Kroah-Hartman at the Linux Foundation. He has been collecting this for years. The way he collects this is if there's somebody that he doesn't know who they work for, he emails them and asks them. You can also use domain names. So company, people who are emailing from their company account, you can use that. So I've actually been working on some of the affiliation data, and it's, there's no easy way to get it because you just don't know, because people contribute from Gmail accounts, they contribute from personal domains, and yet they might be affiliated with a big company like Intel. This question in the back? Yeah. You?
Yeah. Do you know of any good resources or guidelines for how to analyze things like email inboxes or stuff like that, for pulling out data about like projects or products or customers? Because what I'm looking at is analyzing all of the conversations that go back and forth from like support teams or for engineers to find out who are the most costly customers or who are the people who are spending the most time on certain projects.
So are you talking about content analysis, looking at the content of the email to pull that information out?
Yeah. Because it seems like it would categorizing that content and determining if it's about a particular product or something like that. I imagine it's all just keyword searching and stuff like that.
Yeah, you can do some keyword searching with database queries that would get you part of the way there, but I suspect that there's not an easy way to do that. Luis isn't contradicting me, so I'm going to assume there's not.
They're right. At that point, you're almost like talking feature extraction.
Yeah. Mike?
Have you discovered anything about the Linux kernel network yet, or is it still too early to?
It's still too early. Right now, I'm playing mostly with analysis tools. I've actually been working on some job change data. So I've been going through the Linux kernel and looking at who has changed job affiliations. I haven't decided exactly what type of analysis I'm going to run on it. It's pretty interesting. There's a lot of job changes in the Linux kernel, which is pretty interesting because like 85% of these people are paid by their companies to do what they do. But those of them that are maintainers, if I'm a maintainer of a sub project within the Linux kernel community, or a subsystem, that maintainership belongs to me. If I work at Intel, then maybe Intel has a little bit of influence into what goes on. But if I leave Intel and go to Red Hat, my maintainership goes with me to my new job. So the job change data is actually quite fascinating because it takes with it a lot of influence within the community. So I'm interested to look at that. Yeah.
Have you done any sort of clustering analysis that may be interesting? Clustering sort of people within the community, according to certain criteria?
I have not yet. That's also on my list to do. Yeah.
Can you recommend any research or even tooling that gets to that advanced stuff, like the listening essentiality and those kinds of advanced analytics about
The tools that I'm using, R and Vizone, both allow you to calculate those. Yeah, they calculate it for you. But I don't like to show things that where to explain exactly how I calculated that involves like a gigantic formula on the board and lots of math. So that was a little bit easier. But the tools will calculate it for you, but you need to do the due diligence to understand how it's calculated so you understand how to interpret it. Yeah, so the tools do it for you. I'm out of time. Okay, I'll be around. Thanks.